Hi, today we're going to be going through the steps of programming a lathe part. We're going to be doing a 2-axis lathe, turning operations on this part, processing a first operation, and then the second half of the video we're going to be doing some live tooling operations for a 3-axis lathe. This is a radial and axial tool equipped turret with live tools and a y-axis. So we're going to look at performing some operations both on the face of the part and the outer diameter and coordinate systems, and we're going to take a deep dive into programming this part, creating tools, laying it out, aligning the solid model. We're not going to be focusing on the fastest way to program this part today. We're going to be going step by step through the entire process and hopefully providing some tips and tricks that are going to make your programming a bit more efficient and try to provide you with both the how and the why of how we would approach one of these parts. So the GibbsCAM interface we're looking at right now, we just recently released version 25, so it is an updated version. It was just released maybe a month or two ago, but not too much different. It'll be very familiar for you longtime Gibbs users or some of the people that are newly coming in. Now the MDD that we're going to be using, if you go up here into document control, we're going to be using the C-axis horizontal lathe, which is one of the MDDs that we supply, the machine definition document. The acronym's not important, but what that does is selecting your machine and doing it first. That's typically what I would recommend. Is it sets up the axis configuration for the machine, so the software knows that it has an x-axis, a z-axis, a y, the rotary for the c-axis. It lets the machine know the kinematics of the machine and sets that up in the background. So it's always highly recommended that you select the MDD and towards the beginning of the process and not switch horses midstream. I mean, while it is possible, there's a lot of things you may need to check, and it could cause some conflicts later on down the road. So to begin, we're going to be programming in inches. We're here in the US, and these mill classes, that's setting up the tooling configuration for the live tooling. Now this is really just graphics, so we're just going to leave it at Cat 40, and the shank size for the stick tools, we're going to leave that at 1 inch. I am going to be programming in diameters, and I prefer to use auto clearance. So we'll talk a little bit more about that as we get down the road, and I'm going to set that to an auto clearance of 100,000th. We're not going to mess with the stock size right now. We're going to do that once we get our model imported and start playing with that a little bit later. Now up here in the material family, it seems like there's a kind of a split. Some people provide their own cutting parameters when they're creating their tooling process and tool paths. Some people rely on GibbsCAM to generate their cutting parameters, and it does a great job. We have a pretty deep database, and you can customize your materials and have it generate the feeds and speeds that you would like to see. To do that, you do have to provide the software with all the information it needs to give you good starting cutting parameters, which is your RPMs and your feed rates. So you would need to select the material. When you're creating tools, you would need to select the proper tooling materials, whether it be high-speed steel, carbide inserts, solid carbide for drills or end mills, and the proper number of flutes. So you would have to enter a bit more information if you are going to rely on GibbsCAM to generate your feeds and speeds. So I'm going to close this right now, and let's just talk about the basic GibbsCAM interface. So when I'm manipulating the screen, you'll see me moving around the screen quite a bit. I'm using a 3D Connection Space Mouse, which is a peripheral device that I highly recommend if you're going to be doing a lot of CAD or CAM work, and it works across all kinds of CAD/CAM software. And this really helps maneuver the model, the part, and your workspace in my opinion, a bit more of an efficient way. But if you do not have one of those, or it's not something that you like to use, you can manipulate the screen the traditional way. So I have my right hand on the mouse, and I have a wheel. So using the wheel mouse, you can zoom the screen in and out, and it is by default set to zoom in and out where the cursor is. So if I put the cursor on my coordinate system indicator here, it'll zoom into that. If I put it on where the back of the stock would be, it zooms into there. So that's a great feature. Doesn't cost you anything to use the wheel mouse, and zooming in really makes it easier when you have to apply machining markers or select geometry. So get comfortable with manipulating and maneuvering the screen, and it's really going to save you some time down the road. Now, if I push that wheel like a button, I can rotate the orientation of the screen. So I can, by clicking and releasing it, I can rotate my stock all the way around. And then zoom out and zoom back in and kind of get everything a bit more centered there. So you can do quite a bit just by using the mouse. Now, if I want to pan the screen, I'm going to hold Control on my keyboard with my left hand and click the left mouse button. I can grab the screen and drag it to move the part, recenter it. If I happen to zoom off to the side, I can just drag this in and bring it back to the screen. Now, you do have some control with the arrows as well. So if I hold Control and use the arrows on my keyboard, the arrow pad, I can pan my screen up and down. And if I hold Shift, I can also change the orientation of the screen, of the objects on the screen. Now, you do also have in the lower left corner of the screen this small coordinate system indicator. And if I just move over it, I have all of these viewport icons. So I can go top, left, right side, and isometric view. If I should happen to get my object off the screen, I can just hit this magnifying glass here and unzoom and bring everything back centered. And then my home view is going to give me a normal or perpendicular view to the actual coordinate system, which is this grid that you see on the screen. So very powerful tool. You can use the one that's here on the screen, and if you go into your file preferences, you can actually either make this go away or you can change the location of it to any of the corners of the screen. But you also have the same tool up here. So with this tool, you can grab it by the border and put it anywhere, and this way it'll be kind of persistent on your screen. So whether you choose to use this one or the one that appears in the lower left, totally up to you. Many ways to do things within the software, no right or wrong, which way is more comfortable and efficient for you. So I'm going to leave this on the screen for right now. And while this is up, you can actually, if you left click in the center here, you can rotate the view. And if you right click, it'll live rotate the view. So a couple of functions based on the center of this viewport. And before I move off of this, I forgot, if you left click on any of these, as I said, you can change the view. But if you right click, it gives you the backside view. So if I go to my right view, I can do the left view there just by left clicking or right clicking. If I go standard isometric, I can right click and do a total backside isometric by right clicking on any of these icons. So a lot of functionality there. What I'm going to do now is I'm going to open up my coordinate system window, my work groups, and my body bag. Now, this is typically how I have my screen configured. These windows are actually floating palettes, and when you open them up, they'll probably just appear floating out here on the screen, and you can move them around. But by using this, clicking on this icon here, you can actually dock these things to the side of your monitor. So if you have a nice widescreen monitor, it's a bit more of an efficient use of your screen space, but again, no right or wrong, however you want to orient these things, these palettes, that's kind of up to you. Now, I already have my model imported. I imported into the body bag. And the body bag is somewhat just an alternate dimension where you can store models. So when I imported the model, it came up onto the screen. And if I double click it, it immediately goes into the body bag. So if you end up with multiple models on your screen, say part models, fixture models, stock models, you can construction models, you can dump those into the body bag and clear off your workspace so it's a little bit more of a cleaner working area. So when I brought this part in, obviously it's not in the correct orientation for us to do any machining on it. When a part is imported, whether it be from a customer or your engineering department, it's going to come in the orientation in which it was used by whoever designed it. So if you're pulling an assembly out of an engine or a structural component, it may come in very far away from the origin and very far away from where you need to have it to be able to machine it. Now, if you look at the coordinate system indicator, let me put this away for a second. Because I'm using the C-axis horizontal lathe, it knows it's a lathe with live tooling capability. So it comes in already set up with existing coordinate systems. So if you look at the normal view, this is my x-axis, and the arrows are pointing in the positive direction. The z, the arrow is pointing in the positive direction. If I manipulate the screen a little bit, you see I have kind of a little plus sign in the center of the coordinate system indicator. And if I rotate that around, it becomes a minus sign to let you know that you're looking at the negative side of the coordinate system. So in my coordinate system list here, and again, I like to see it on the screen, but the button to turn the coordinate systems on and off, it's a two-part button. So if you use the bottom portion of the button, it has all the same functionality that you do in the palette here. And the same thing with your work groups. Work groups, some other software calls them layers, but those are different layers of the screen, or work groups of the screen, that you can put different layers of geometry. And we'll talk more about that in a little while. So again, at the bottom portion of that, you have all the same functionality that you do with having the palette on the screen. So whether you use the bottom portion of the button or use the top portion to turn it on or off, totally up to you, no right or wrong. So the coordinate system configuration we have for the C-axis horizontal lathe is we have our ZX plane. That's coordinate system 1 here. So this is, in general, your turning coordinate system that you're going to be using for all the turning operations on this part. You have your XY coordinate system, and that's really what we're going to be using for the live tooling operations or any live milling that we're going to be performing on the face of the model. This HY backside, we're not going to be using that for this exercise. And the YZ coordinate system, and this is in general what we're going to be using for any radial milling operations on the periphery or the diameter of the part. And again, we're going to be taking a much deeper dive into these coordinate systems a little bit later. So in general, most of the time you'll have all the coordinate systems that you'll need for most parts, but it's very easy to create, manipulate, and modify coordinate systems should you need to create more depending on the parts that you're machining. So I'm going to bring my model back out, and I need to get this thing oriented. So if you notice, when I click on my model, it selects the entire model, and if I click off in space, it deselects it. If I double click it, it goes into the body bag. Double click it in the body bag, it comes back out into the workspace. Now I have some selection function tools up here on my floating palette here. So if I click on this first button, you'll notice that I can click specific faces of the model. And if I hold down Control, which is my multi-select button, holding Control allows me to select as many faces of the model as I want for whatever purpose I need to do to them. Again, click off in space, deselects. Now I have edge selection. So this is visible edge selection. So you kind of see that all of the edges and vertices of the model are highlighted. So I can actually zoom in and click on edges of the model. By holding Control, I can select multiple ones. By default, I can only select one at a time. And again, clicking off in space deselects. So we're going to use face selection, because we need to get this part oriented so that this face here is at my Z0. This is going to be the front of the part that I'm going to be machining. So I'm going to go to my XY coordinate system. I always find that this is the easiest way to orient an imported part. And what I'll do is use face selection. So you can do this in a couple of ways. Very easy to do. I can select this front face of my model using face selection. And all I would need to do is right click on it and align this face to the coordinate system. And once I do that, my part is on center and aligned to that coordinate system. Now I'm going to use Control Z. Control Z is the same thing as using this undo button up here and put it back to where it was. because I can also select this outer diameter, right click on it, and align that to the CS, and it takes this outer diameter and aligns us properly to the coordinate system. So you don't need to go up to modify and 2D rotate and create other coordinate systems. You can just select one of your active coordinate systems, select the face that you want to align to it, and get it in the proper position. So we're on center. We're pretty happy with that. Now, if I go back to my XZ coordinate system, it's on position to turn. If I go to my XY, I can do the milling on the face. But if I go to my YZ, I notice that these two outside flats on this conical feature are not clocked to this coordinate system. Now, it's not a big deal. If I wanted to leave the part in this orientation, I could just create alternate coordinate systems to machine these two flats. But sometimes it's nice to use what we have. So I'm going to take another step, and I'll select this face here. And if I select this face, I can then right-click and align that face to the coordinate system. Now you see it aligns this face normal to my YZ coordinate system, but it does throw my part off center. So all I would need to do is go back to XY, reselect the face, right-click, and then align it again. So now you'll see that in my YZ, my flat is clocked to the existing coordinate system. I'm on center, and it looks like I am all in position to be able to start machining this part. At the top of the screen, you have a modify drop-down. At the bottom left is a tool called Shrink Wrap. Now, if you look at your stock size, the stock size, this grid and cylinder, is generated by what you see down here in Document Control. If I close this out and go back up to Modify, the Shrink Wrap tool kind of acts like a cling film. It takes the stock size and it shrink wraps it to the size of what you have, whether it be model or 2D geometry on your screen. So by clicking that button, you see that my stock is now the exact same size as the part. And if I open up my Document Control, I can see that the part is roughly 3 inches in diameter. It has no stock on the face. I'm going to zero this out. And then it's 4 inches long. So by going into here, we can now set up the actual stock size of what we're going to be machining. So for here, we're going to use it as 3-inch material. We're going to pretend like we're going to do a first operation on this part and just turn back to this wall here. And then this is the stock that we're actually holding in the chuck or the collet or work holding of our lathe. But I am going to add a bit of material on the face of the part. So if I go to Home View and zoom in here, right now our Z0 is right at the face of the part. So I'm going to add 50 thousandths worth of material that we're going to face off, as if we took these slugs off of the bandsaw, and we have some saw cut material right here on the face of the part. And you see if you needed a bit more material, if you needed an 1/8 inch of material, or depending on the diameter of the part, 1/4 of the material, you see that the stock automatically changes as you enter the information in your Document Control. So I'm going to go back to 50 thousandths. And it looks like our stock is properly set up. We're still in auto clearance and diameter. Our units is inches. You can program in millimeters and still output your G-code in inches, and vice versa. Program in inches, output in millimeters. That has to do with your post-processor. But for this exercise, we're going to be in inches. So I can close my Document Control, and I think we're ready to start generating some tools and toolpath. So I'm going to open these buttons here. This is my tool tile list, which generates a row of tiles on the left side of the screen. And then I'm going to open up my CAM button. And the CAM button will generate tiles beneath my tool tiles here in the lower left, and then over here in the upper right. And I'm going to reposition some things on my screen. Now, this essentially illustrates the basic workflow of GibbsCAM. So in the upper left, this is where we're going to be generating our cutting tools. So you can think of this like the turret on your lathe. You have all these tile positions and tool 1, 2, 3, 4 moving down the line. below this clear button is a row of tiles, and you can move this up or down if you want to see more of your processes or more of your tools. And this is where essentially your work in progress is going to exist. So when you're actively creating a process, a roughing process, a tapping cycle, a drilling cycle, a turning contour, all of that information is going to be down here on the lower left. Now, when you've designated your feeds and speeds and your process and your rough stock and lead in, lead out, everything you need to generate the toolpath, once you generate the toolpath, it will end up here on the right side of your screen. So the right side of your screen is going to end up being a running list of all the operations that you have created for processing this part. So to create a tool, all I would need to do is double click on tool tile number 1. And in here you get a list of milling tools and turning tools, and in the case of the options I have on this system, I can create probing and broaching operations. You see the specifics for the insert. This right here tells you the touch-off point for your particular tool. You can associate tool stick out and the offset numbers for your tool call. And you can add comments down here. Now in the lower left is an active window where you can actually see the tool, the insert, and some generic tool holders that come with the software. So for this exercise, we're not going to use tool holders. I'm going to turn that to off, so all you see is the insert. So to generate this insert, I'm going to use this touch-off point as if it's sticking out of the turret in the machine. And I'm going to tell it that it's a 1/32 nose radius, a 1/2 inch inscribed diameter, and a 3/16 thick. So that is going to be a 80-degree insert with these dimensions for the insert. So this is essentially a CNMG 432 insert. Now if you notice, the touch-off point, which is down here in the red, isn't clocked correctly. So I would simply need to go down here to my diameter relief or my face relief. These will auto-calculate to each other. So I know that I need 5 degrees diametric relief, and then you'll have 80 degrees for the inside of your insert with 5 degrees of relief on the face, and also 5 degrees on any diameters that we should be machining. Now within here, you can set your tool material if this is a carbide insert coated, and the software does need that if you're going to rely on this to generate your feeds and speeds, which we're not for this exercise, but you would want to put that in there. And one of the things I always advise is if you wanted to add additional information in your comment box down here, it's really going to provide you a lot more assistance down the road. So this will come up when you hover over the tool tile, and this will actually output in your program. So if you wanted to put in something like an 80-degree OD roughing insert, you could put something like the EDP number 1, 2, 3, 4, 5. You can put cabinet 6, drawer 7. You can put the physical location if the operator did need more of these inserts. But any information you think would be useful to the people processing this part, go ahead and put that down in your comment. And then all you simply need to do is close this tool, and your tool is created. Now if I go up here and hover over the tool, you'll see that comment right there. So if you end up with 2 or 3 80-degree inserts, they're all going to look the same on the tile. Just hover over it and it'll give you a deeper description of what you're looking at. So that's as simple as it is to create a tool. Now I do need to know what I'm going to be machining. So what I want to do is pull off a turn profile so I have geometry to apply my tools to. So if I go and look at my model, you can see that the XZ coordinate system, the ZX plane, that's my turning coordinate system. So I need to pull this profile of this part. Now that's why I'm going to look at this third tool here called the profiler. Now if I turn on the profiler, it creates this translucent grid, and it essentially cuts the part where the grid is. So if I look at it, it's actually cutting through the part and I get kind of a turn profile, but with this flat, it drops down into the flat and there's a counterbore hole here. And I also have these splines here, and it's to the bottom of the spline because that intersects that slot there. That is not going to be usable geometry. So there's a drop down here on our profiler. So if I go to the second box under the profiler icon, it's slice spun body. So if I switch to that, that now gives me a clean as turned profile of the part on center. And it only gives me the top half because that's the only geometry that I need. So it's totally ignoring this flat and the cross holes on the outside of the part. And it's also giving me the major diameter of this and ignoring all of these splines around the front of the part. So that is what I want to use. That's the mode I want to use for my profiler to pull the turn geometry for this part. Slice spun body. Now once that's on the screen, I'm going to select it. I left click on that geometry and it's highlighted in deep blue there. Then once I left click and select it, I'm going to right click and I'm going to extract that profile. Clicking on that opens this geometry extraction button. The tolerance, you're always going to have that at 0. That shouldn't change. And I'm going to click do it. And if I click do it and then click off in space, turn off my profiler, I can see that I have nice geometry for my part. When I use the term geometry for this tutorial, geometry means lines, circles, arcs, points, any 2D geometric geometry. If I'm referring to the model, I'll say solid model or face of the model. But when I refer to click on this geometry or click on that geometry, I mean lines, points, circles, and arcs. So I'm going to put this model away in the body bag because I think we're kind of done with it for right now. And one of the things I do want you to note, a tip, is that when you double click your part and put it in the body bag, notice the color of what it is in the body bag. It's still yellow, which means it's still selected. So if I were to then click on my geometry, say I wanted to delete it and I hit delete, I can either hit delete on the keyboard or click on this trash can. It's going to delete my model as well, so that's not good. It usually will give you a warning that you're going to delete a model to give you a little second chance to deselect it, but be careful when you put things in and out of the body bag because when they're yellow, that means they're still selected. So get in the habit of when you bring something out, click off in space, whoops, just click off in space, or when you put something in, click off in space to deselect it. Just kind of make that part of your workflow. Get used to deselecting objects to reduce the risk of you accidentally deleting them. I'm going to double click my part, throw it in the body bag, and deselect. Now I'm ready to do my first operation. So my first operation, I'm going to simply do a simple pass down the face, leaving a little bit of material for a finish pass. So for my facing operation, I'm going to go into my home view here just to make things a little bit easier. And this tool that I created, this CNMG 432 roughing insert, I'm going to just bring that tool down and drop it onto my tool process tile number 1. And then I get all the operations possible with an insert of this type. So I don't need to rough this. I've only left 50 thousandths of material on the face. I can do one single contour pass, leaving just a bit of material for my finish tool later on. So when I bring up my contour process window, this is all the information I need. This is going to be my feeds and speeds, my remaining stock, my cut directions. So in going through this, the first thing I want to look at is, am I machining on the OD of the part, the inner diameter, or the face of the part? And obviously I'm facing this part off, so I'm going to be machining on the front face. I am going to be cutting in the forward direction, and you'll find that 99% of the time you will be machining in the forward direction. And we'll talk about some of these other options later. Now for my entry and exit, in general for the lathe, I'll be in line and I'll have these zeroed out. Now you can put in custom lead in and lead outs for different contour processes, but for this one I really wouldn't need anything, so I'm going to leave those both at 0. There's some options down here for breaking chips if you're using stringy materials. like some stainless steels or Teflon or some composites, anything where you're generating stringy chips. There are some options which we'll talk about when we get to the roughing portion of this. I'm not going to take too much of a deep dive into the cutting parameters. We're going to be using constant surface speed mode. This is where you would set your G50 if you're running a FANUC control, your max speed limit, something like 3,500. This will be your surface feet per minute. And again, if you're using FANUC code, this will be your G96 constant surface speed here. Entry feed. This is the entry feed from the rapid plane. Once it gets done rapiding to my approach point, 100 thou away from the cut, it'll use this entry feed. So I usually bump that up a little bit faster, and then you get to your actual cutting inch per revolution feed rate here. Now I am using auto clearance. Auto clearance is the distance from the actual cut that the turret will wrap it to. So I'm going to wrap it to my auto clearance point, which if we remember from our document control, we had set to 100,000. So I like to use auto clearance. I'm a big fan of using that. Should you not want to use that, you can set your custom approach and retract distances. But as I said, I'm a big fan of using auto clearance. I am going to be using material only, and we'll talk about this more a little bit later. And I'm going to set my clearance to 100 thou for this particular operation. Now you can set up automatic corner braking, which I wouldn't need for facing this part. And then you have finish stock here. So you have 3 modes for finish stock. So finish stock is kind of a universal stock that you're going to leave on the part for a subsequent finishing operation. So if I put 5 thousandths in there, it would leave 5 on the faces and all of the outer surfaces, the diameters and the IDs. I like to split them up. So for this particular part, I'm going to leave 10. And you notice it says X radius, so that's 10 per side. So if I were to turn apart, it would be 20 thousandths oversized because I'm leaving 10 per side. And then I'm only going to leave 5 thousandths on all of my faces. Now, cutter radius comp, that's tool nose radius comp. I don't really need that for this particular part. Cutting load variation. If you have a newer machine and it has a variable spindle speed setting that you can turn on in the control, you can activate it by selecting this button here. And then I have my coolant options. So now you notice I do not have a green checkbox for do it or redo. If I did have a green checkbox, when I click it, it will actually generate the tool path. And your do it and redo here is the same thing that is right here, functionally exact same. And if I right click off in space, I have a do it and redo out here in space. They all do the exact same thing. Now the process just needs to know what in the world I want to machine. So I have to apply my contour markers to this part. So the way I like to do it is I'll zoom into the face of the part. I am in my home view, so everything's nice and flat. I'll zoom in. And I click on the middle of this piece of geometry. Now you end up with this sequence of this graphic here on the geometry. So essentially you see 3 circles. Left circle, center circle, right circle. All that does is tell the software what side of the geometry that you want the tool to be on. So obviously I want the tool to be on this side, so I'm going to select this circle. These 2 arrows tell it which direction do you want to be machining. So I want to be coming to the outside diameter of my part and facing downward. So I want my blue arrow to be facing downward. Now the squares belong on the contour geometry. So we're going to leave these black square and white square alone. But the circles denote the extensions of the face pass or the cut. So I'm simply going to take this white circle and drag it somewhere outside of my grid, which is outside of my stock. And then, so that's where the tool is going to start machining. Now the black circle, I could drag this down and put the tip of this arrow somewhere at the X0 place. But it's not as accurate by dragging this one. So on this particular operation, I usually only do this with my facing operations, is you can also right click on it. And then you can actually move the start and end points by putting in a number. So I do want to move the endpoint. The endpoint is the black circle. I'm simply going to take my XD and just type 0 in there. Now I do have to click in one of the other boxes to get the number to take, and you see now that this extension of the toolpath ends up at XD 0, which is where I want to be. I can close this, and now I do have my green checkbox. So I'm going to click that, and there is my face pass. So if I can zoom out, and then I can use my OpSim to simulate my toolpath. By going up to my OpSim button, I can turn on my operation simulation. So your OpSim rendering palette has a lot of tools in here to visualize the toolpath machining the actual stock. Now this blue cylinder is the stock that's represented in my document control. So I have 50 thou on the front, it's 3-inch diameter, and it's 4 inches long. Now before I click play, I have this speed control slider down here at the bottom, and it's set pretty quick. So I can slide this down 25 or 30% of the way to slow down my rendering. And if I click play, you can see my insert come down and face my part. I can hit rewind and I can watch that again, or I can hit rewind, and I also have a single step button here. So you can kind of single step through the operation. Now I also have a quadrant button here, show lathe stock cutaway. So yours may default to this view here, kind of looks like a pie shape is cut out. So if I were to render the cut in this view, still renders the same, but these cutaways help you visualize internal operations if you're drilling holes, if you're doing internal boring or grooving. So we'll use those in later views. And that's 3 views there, so you can toggle through a half section, full section, 3/4 section. So this gray cylinder here will help you visualize your cuts a bit better. So that all looks fine. My OpSim, and I'm going to just simply close that, and I'm ready to move on. Now when I'm done and I'm happy with a toolpath, I always go through this very simple process, and I just simply click on any empty tile over here on the right and deselect it. Then I'll hit clear over here on the left, and then I'll just go up and hit my file save icon. Now you don't need to do any of that, but it's kind of a great habit and a great practice to get into to constantly save your work whenever you've accomplished a task. And creating a new toolpath is a great way to do it. If you're doing a very complex toolpath, you may want to save in the middle of that, but getting yourself into the habit of saving your work is always going to save you a lot of headache later on. Okay, so I have that process done. Now if I wanted to make a change to it, in GibbsCAM, it's software made for machinists. So it's made to quickly go back and make tweaks. So to reawaken that toolpath, say I needed to change my feeds and speeds, all I would need to do is double click on that operation tile on the right, and then it applies my markers, gives me my entire selection of marker directions, and it reawakens the process over here on the left hand side. So all I would need to do is go in here, and I could double click, and I could maybe increase that feed, try to decrease my cycle time a little bit. Click redo, and the toolpath has been redone. So no big deal there. It's very easy to go in and make tweaks and changes within the software just by double clicking on any operation tile over here excuse me, on the right hand side. So again, I can close that, I can deselect, hit clear, and I'm going to go ahead and save again. You can hit this disk here to save. You can go File, Save here. You can also use Control S to save your work. Any of those 3 ways will save your work, and I highly recommend doing that often. Now, let's move on to our second process. So I'm going to now use that same tool to rough this outer diameter. Now I'll bring that insert down again. I will do a roughing process. And roughing process looks very similar to contour. You just have a few more options in here. Starting at the top, again, I am going to be machining on the outer diameter of the part. I am going to be cutting forward, and it defaults to the rough side of turn, which is fine. That's what I want. Now I can put in my depth of cut here, and let's just do something, we'll keep it at 80 thou. And that's XR again, that's to the radius, so that's 80 thousandths per side for your depth of cut. We'll talk about some of these options a little bit here in a second. We're not going to talk about the cutting parameters again, we'll just leave what it defaults to. And again, we are going to be using auto clearance. We're going to be using material only, and I'm going to set this to 0.1, that's my preference. Start side extension, corner break, we'll talk about some of these options later. And this is a roughing operation, so I'm going to put 10 thousandths worth of stock per side to leave for a finish pass, and 5 thousandths of stock on all of the faces that I'm going to be machining. So I'm happy with that, so I'm now going to apply my processes. So I can close this out, and I'm going to start roughing this from this chamfer all the way back to this vertical shoulder here. So I like to click right in the middle of the line, and again I like to zoom in, make my selections easier, and click right in the middle of that line. So you have two circles here to denote which side of the tool that you want the what side of the geometry that you want your insert to be on, and obviously I want to be on the right side. I'm just going to simply drag this white circle down along this line, because remember we're selecting this line, so I can only click and drag this in line with that geometry. I couldn't drop it out here or anything. So I'm just going to drag this outside of the grid of my stock, and I need to set my end marker, which is my black square and my black circle, on this line. So I could manually drag this to whatever geometry I wanted to end on. But what I can also do is I can hold Control and Shift at the same time. I usually do it with one finger, but you can use two. If you hold Control and Shift, it turns your cursor into this little plus. And if you just click on that line, it moves your markers there as well. So a little time-saving trick. And then I'm simply going to drag my toolpath extension, my black circle, outside of my material. So my marker setup kind of looks like this. And if I click Do It, there's my toolpath. Now you'll notice the toolpath ignores my toolpath extensions from my white and black circle markers. If I click Redo, it just simply creates toolpath where it knows that there's material. So if I go into my process, I'm using material only. It's smart enough to analyze previous processes and know where I have material and where I don't. So I can turn it on full, and then if I tell this my stock size is 5 inches in diameter and click Redo, you'll see it'll cut to whatever diameter I want, and it will also pay attention to my toolpath extensions. So limiting that by using material will save you a bit of time by letting the software decide where it needs to apply the toolpath, and you can be a little bit less precise in where you set your toolpath marker extensions. All right. So one of the things you'll also notice is that because my tool geometry has a 5-degree back turn angle, it's trying to drop that tool into these OD grooves and also my relief down here on the front of the part, which is not a huge deal depending on the material, but it also may rub the insert and generate some heat and reduce tool life, things like that. It's probably not something that you would really want to do. So to alleviate that, what I can do is use my cut direction axes down here. So right now, all 4 axis directions, Z plus, Z minus, X plus, X minus, are active, so the tool can cut in all 4 directions. But what I can do is disable X minus, and that will prevent the tool from being able to travel in the X minus direction. So by disabling that and clicking Redo, the tool will now ignore these slots and the relief and not drop down into the part at those points. So if I go now into my OpSim, turn this a little bit slower, and I can click play, and there's my face pass, and then here is my roughing operation on the OD. Now if you notice, if I turn this a little bit more, the front of my part is gray, but the outside of my part is being cut in yellow. That is because that is the operation that I have highlighted in yellow. So whatever you have over here in yellow, that's what's going to be yellow on the screen when you do your OpSim rendering. All right, that looks good. Use my quarter section view if I wanted to analyze that. What you can also do is if you are using your quarter section view, you can turn on overlay geometry. And what that does is it takes the geometry and applies it on the screen inside of your OpSim rendering mode. So if I zoom into that, I can see that I've left material on the face, that 5 thou, and it's a bit more on the diameters because I decided to leave 10 there. You can see the radius of the tool and how much material that leaves in these sharp corners, and where it's actually cutting and how it compares to the geometry on the screen. And that's using your overlay geometry button here. So I can turn that off. I can turn my OpSim. And I'm going to deselect. I'm going to hit clear. And I'm also going to click save. So there is the face rough and OD rough. Now I do have a hole through my part. So I'm going to bring my model out just to kind of remind you what the part looks like. And there's a through hole there that we need to drill. Now, in determining what size hole that is, obviously if you have a 2D drawing from your engineering department, you could use that. But what you can also use is your solid model. So if I go up here to plugins, I can go to this button that says show position. So if I use show position, it brings up this little window here. And if you click on the icon, you can see the actual position that you click on. You can measure thicknesses, and you can also check curves. So if I select my model and then click on that curve, you can see it gives me the radius of that through hole. And that's 0.3125, which means that the diameter of this through hole is 5/8 of an inch. And if I click on any of these radiuses, it will give me, or any of these diameters, it will give me the radius. So this neck diameter here is 5/8, and it tells me my stock has 1.5 inch radius there. I can also use it to check thicknesses. So if I clicked on the part here, you see that line on the part. It tells me that at that place, it's 3.97 thick. Or if I click on this face, it tells me that this shoulder, my clamping diameter, is 1.2 inches. So it's a pretty powerful tool using show position. So if I put that away, back in my body bag, remember I deselect once it's in there, and just pull my geometry back up, I also have a dimension palette. So in using my dimension palette, say I wanted to check a linear dimension, I can click on horizontal, and these linear dimensions operate by points. You can see it needs points there. So I can click on this point, and any other point that I hover, it gives me a little temporary dimension there. So my overall part is 4 inches, and when I move off of it, it disappears. Now if I wanted that persistent on the screen, I could click on that, hold Control, and click on it, and then it gives me a linear dimension there. Now the font is a little bit small, so what you can also do with your dimension palette is if you right click on this top bar, you can actually change the font. Now the font is fine for me, but I typically change this to 18. I like to see the geometry a little bit bigger if your eyes are getting bad, or if you have a relatively small monitor, or if you're printing out the screen cap, if you're making a sketch for your operators, you can make the font size a little bit bigger there. So in showing this, another way that you can find out what diameter this through hole here is using my point geometry tool. And it's just an angular line pointing to a single point. And if I click that and click on either the front or end point of this line, it gives me all 3 coordinates. It tells me my Z position in relationship to my X and Z 0. But it also gives me an XD, that's a diameter. So it tells me that this line is at 5/8 of an inch. So a couple of different ways to determine tool sizes and hole sizes and feature sizes from both the model and the 2D geometry. So I'm going to go ahead and close that palette out. And if I want to delete geometry, I always find it's easier to just click on the leader line. And then again, you can click on your trash can, or you can click delete on your keyboard to get rid of those. So I'm going to click on the leader line and just click on delete. So I do know that I need to drill a 5/8 hole all the way through my part. So let's go ahead and create our tool. So I'm going to create my second tool. and I'm going to create a drill. Now I do need to pay attention to my orientation, and I know that this tool needs to be oriented towards the chuck, so I'm going to face it in that direction there. I'm going to type in my diameter. Now it's 5/8 of an inch, 0.625. If you're not great with fractions, or say you get a weird hole size, like you need to drill a hole that's 23/64 in diameter, you can actually put in a fraction. So any box within GibbsCAM that you have to enter a number, you can use as a calculator for basic math functions. So for instance, I can take and put 5 divided by 8, 5/8 of an inch. And if I click equals, it automatically calculates that. This also works to convert inch to metric. So if I knew I wanted a closer drill, like say a 16mm drill, I can hit I on my keyboard and it will convert that to the decimal equivalent of 16mm. Or I could take and put 0.625 in there and I can hit M and it will convert it to the metric equivalent of that decimal number. So using I and M will convert from inch to metric and back and forth there. And you can also do basic math. So I'm going to put 0.625 in there for my tool diameter. I'm going to put in 140 degrees if this is a spade drill or replaceable tip carbide drill. And again, because I can do basic math in here, I can put in math. So I'll put in 0.625 and I'll go times 5. So a lot of times when you're using carbide drills or you're buying inserted drills, it'll have a ratio of diameter to the length. So it's a 3 times D length drill, 5 times D, 7 times D. So if I put in my diameter times 5 and hit equal, that gives me a cutting length of 3.125. Now, as we know from our document control, our part is 4 inches long, so that lets me know that the cutting length for a 5 times D drill isn't long enough to get through the part. So maybe I'll put in 0.625 times 7 equals, there you go, 4 3/8. I'll give it a little bit more length there for my shank, just to have a more representative tool here. And I think I have a good tool, 4 3/8 cutting length. And we'll just tell it that this is a carbide inserted drill, one of a replaceable tip 140 degree carbide drill. So my tool is created, and I'm going to bring that down. And if I bring that down, I have 2 options here. I have a live drilling option, which is if you're going to have a live tool and then your chuck is stationary, or a lathe drilling option. Lathe drilling means your chuck is going to be spinning, but your tool is hard mounted and your tool is stationary. So we're going to do a standard lathe drilling hole here. So we have a lot of options here for drilling processes. So if I were going to be drilling, I have my feed in, wrap it out, my my standard G81, G82, feed in, wrap it out, feed in, feed out, like you would use for a reamer. I have my tapping cycles here, and a lot of the newer machines have peck tapping cycles. If I wanted a peck drill, I have peck, chip break, and I have variable peck, where you could start the first peck at 100% of the diameter of your drill and have slowly decreasing peck depths until you get to a minimum peck size. And then you have gun drilling options. So you have a lot of control about your spindle depth feed rates, that if you're using very deep hole drills such as gun drills, you have a lot of options there. But for this, we're just going to do a standard feed in, wrap it out. I'm not going to worry about our cutting parameters here. And then I have here where I set all the depths. All the depths are going to be controlled from the process. So I typically start in this lower left. And this lower left where it says 0, you see it has this little line that's drawn to what would be this representation of our stock. So this is where we're going to be drilling in Z. So we're going to be drilling starting at Z0. Now I know we have 5 thou left on the face, but we're not going to worry about that. We're going to start drilling at Z0. Then these other 3 boxes auto-calculate to each other. So if we were using a spot drill or a countersink, we could put in the diameter of the spot or the countersink, and that will auto-calculate the depth of the tip of the tool in the corner of the drill. Or you could put in where you want the corner of the drill to go, which is really better if you're drilling through holes and you need the corner of the drill to break through the back of the material. Or if you're drilling a blind hole and you just really care about not breaking through the back and you want to designate where the tip of the drill is going, you see this arrow, and this has a little line that goes down to the tip of the drill. So we're drilling through the part, so we care about where the corner of the drill goes. So I'm simply going to click in that box, and we're going to use a function called interrogate. So if I hit the Alt key on my keyboard with my left hand, if I click on and off, it turns my cursor into a little square. But if I hold that down and click on this back line of my part, it enters the Z distance for that piece of geometry in the box, so I don't have to reference my drawing. As a matter of fact, I could hold Alt, and any feature that I click on, it will automatically populate with the Z distance of that feature, whether it be a line or a point. So I can quickly go through and interrogate my geometry and my solid model to pull distances and dimensions from entities already in Gibbs. So I'm going to go in here, I'm going to hold Alt, and I'm going to interrogate this back line, and I know that's the back of my part. So I want to clear that a little bit more, so I can just simply put a little bit more depth on there so that the corner of my drill breaks through 50 thousandths through the back of my part. Now, I already have a green checkbox, so it has everything it needs to attempt to create toolpath. And because we're lathe drilling, we know it can only drill on center, so there's nothing I need to select. I am going to be in the XZ coordinate system. So if I click do it, there's my drilled hole through my part. And if I go into OpSim, I can go ahead and rewind and click play. I'll speed it up a little bit. And there's the hole drilled all the way through my part. All right. I'm going to deselect there, hit clear here, and hit save. Moving on to the ID of the part, now that I have my hole drilled, I have a chamfer and a small ID bore which goes into an ID groove relief here. So I'm going to create a boring bar insert. So I'm going to double click on tile 3. I'm going to use an 80-degree insert. I'm going to go none for my tool holder. So let's do a 64th corner radius, 1/4 inch included circle, and 3/32 depth. And I'm going to change my touch-off point to here, more representative of a boring bar. I'm going to make sure my face relief is set to 5 degrees, and there is my insert with my touch-off point in the corner. You always want to check this picture and make sure the insert orientation looks like what it's supposed to look like in the machine and the touch-off point is in the correct location. Otherwise, your geometry isn't going to generate correctly. So there's my boring bar insert. I'm going to bring that down. And I'm also going to create a roughing process because we need to rough out this ID here. So if I go to rough, we are in this instance going to be machining on the front ID. We're still using a rough turn type. But because we're using a relatively small boring bar, I'm going to change my depth of cut to maybe 30 thousandths. And then I'm going to use auto clearance. Material only, I'm just going to keep that the same. I'll use a little bit less stock on the diameter because it is the ID. So I'll go 5 thou on the inner diameter and then, or inner radius, and then 5 thou on the face. So in setting my machining markers, I do want to start on the chamfer of the part. I'm going to extend my cut here. I'm going to cut in this direction. Now again, I need to set my black circle and black square at this vertical line. So I'm going to use Control and Shift and set my end markers to that line there. And I'm going to bring my extension down into the hole that I drilled. Now you see everything in between my start marker and my end marker is highlighted in this bright blue color. If my tool were selected, if my arrow were in the other direction, you see it would highlight the outside of my part. And that's a good indicator to let me know, whoa, I need to check my arrow direction. So that looks good there. I'm going to click do it. And there's my toolpath with my 30 thou depth of cut. Now, same thing we had with the OD of the part. You see that the tip of my insert, because I do have 5 degrees of back angle on the insert, tries to dive into that relief. This is just a matter of going into my process and telling it, once you start machining, do not allow it to travel in the X plus direction, which would be towards the outer diameter of the part. And if I click redo, it no longer tries to dive the insert into that relief. So I'm going to close that, deselect here and clear, and I'm going to go and file save. Now I have my ID rough pass going. I can run my OpSim. I'll rewind and play from the beginning. OD rough there, drill, and then I have my ID bore. If I overlay my geometry, I can see how it skips that ID groove section there. All right, we're making good progress on getting this part turned. Now that the part is totally roughed, we've roughed the face, the OD, drilled the hole, and done the ID, we can work on our finish operations. So for our finish pass, I'm going to create a V-style insert. So a V-style insert has a 35-degree included angle on the nose. I'm going to generate my correct touch-off point because this is an OD tool. Let's give it a 64th corner radius, a 3/8 included scribe diameter. The inscribed diameter is if you drew an imaginary circle in the center of the insert that touched all 4 sides, what the diameter of that circle would be. And it's going to be 3/16 thick. Now typically with VNMG or VCMT inserts, there's typically a 3-degree face relief, so I'm going to put 3 degrees in there just to give me a little bit of clearance for so my insert doesn't rub. All right, that tool has been created, and let's go down and do a quick face pass. Now my nose radius is 1/64th, roughly 15 or 16 thousandths, but I've only left 5 there, so it's fine to use a V-style insert to face that little small amount of material. So I'm going to do a contour operation. I'm going to be on the front face of my part. I'm not going to worry about my cutting parameters. And I'm going to zero out my stock because this is a finish pass. So I'm going to set my markers here. I'm going to cut in the down direction. My tool is on the correct side. And I'm simply just going to move my markers up and down since I'm only cutting here. Now when I click do it, there is my finish pass, a little straight line into the cut. It goes past the edge and then out. And because, remember, I've used material only, it's only going to apply toolpath where it sees material, and it knows the ID's been rough, the OD's rough, so it knows there's only material on this front face. So there's my finish pass. Now, I need to machine this OD here, finish machine the OD. So instead of clearing, deleting, I can convert this because I am still using tool 4, I am still using those finish cutting parameters. I can simply just double click in here, open it back up, change it to OD, and then I can set the markers for my OD pass. So I'm going to click on this chamfer, move this down here, and I'm only going to face this just to this vertical wall here, and I'll talk about why for us in a second. So I'm going to hold Control Shift and set my back markers here, and I'm going to machine up this wall here. So if I don't want to click redo because remember I'm still active on my face finish pass. I'm going to click do it and create an entirely new operation. And when I click do it there's my finish pass starting here below the chamfer, dropping down into this relief and up this face. And that's why I did split this finish pass into 2. I'm going to finish this first section and then I'll finish the second section. Because I want this enabled in all 4 axes, I do want that tool. Oh, wait a minute. I never roughed this tool. Roughed this part. So this is a great way to talk about going back and forth between operations. So I did the finish pass before I went back and roughed this section. So it's a great point to jump off and talk about that. So I like this finish pass, so I'll keep it. So I'm just going to click clear here. And I forgot to rough this with that tool. So obviously if I were to bring this finish pass in here, I would most likely snap off the tip of my tool because there's a lot of material still in there. So what I'll do is I'm just going to bring that down and create an empty space. So rearranging operations that you've already created over here on the right hand side is very easy. It's just a matter of clicking and dragging to rearrange operations. If you wanted to add empty spaces, you could hold shift and all these little triangles in between the numbers. If I wanted to create an empty space in there, I could hold shift and double click and it inserts an empty space in between those tiles. If I wanted to put one here, I could, and here I could. And this is kind of the way I generally program. I usually leave an empty space to denote tool changes for me. It doesn't really matter, but that's just my practice. You don't have to do that, but that's just the kind of the way I've become accustomed to working, is leaving empty spaces in between the tool changes. Now on this one I left an empty space because I want to put a roughing pass in there. So I'm going to bring that tool back down. And I'm going to right click and change the process to a rough. I need to do a roughing in there. So I know I need to do roughing on the OD. I'm going to keep my small depth of cut because I have a V-style tool, which is a relatively delicate tip. So I'm going to also leave 5/1000ths of stock on my radiuses and my faces. And I'm going to set my markers to rough this relief out. So I'm going to set my marker here. I'm going to hold Control and Shift and set it to this back face and move this up. So this is the only area in which I need to rough, and I don't really care about where I set my extension markers because I'm set to material only. So I want to put this process in between my roughing face and my roughing OD. Or if you wanted to put it before the face, you could do it here. Maybe I'll put it here. So whatever block I click in and make yellow, when I click do it, that's where my toolpath is going to end up. And so I click do it, and there's my roughing of the groove. And you see in the order of my processes, I'm going to bring up tool 4, which is that VNMG insert. I'm going to rough this groove. Then it'll come in and finish the face. And then it'll finish this first segment of the OD. And I think that's going to be fine there. Now I can do the rest of my OD finish operation. So as I said, I want to put that operation here. I'm going to go back into my process, and I'm going to set my markers back here. I'm going to hold Control Shift and click on this back line, drag this up. I'm cutting in this upper direction. My tool is on this side, and I'm going to click do it. So now it's finishing this OD, but it is dropping into these O-rings. And these grooves I haven't roughed yet. So again, to go into my process, I can deactivate my X minus so that the tip of the tool will not drop down into these grooves, and redo. So now the entire outside of my part, the OD of my part, is finished. So if I go into my OpSim, I'm going to rewind and play. Drill, rough the ID, there's roughing the groove, and then there's doing the finish pass on the OD. Now with your finish pass, sometimes depending on the material, when you're taking that insert and cutting up a face, because you have a decent amount of contact between that insert, there's only 5 degrees of relief there. Sometimes you get a big ribbon chip, sometimes you generate a bit of heat there. We do have a function called no drag. And if I click no drag and then redo that operation, you see it adds retracts in here. So it will actually cut down the angle, cut in the OD down here, retract up, and then cut down any of the faces, so you get much better cutting action. So if I go into my OpSim, there's a new feature that you can use if you just want to jump directly to that operation and not have to render all the ones before that you've already seen a few times at this point. And that's called Skip Unselected Ops. So if I click Skip Unselected Ops, it will go through the part and pre-cut all of the operations prior to the one that you highlighted in yellow. So now if I slow this way down and I click play, slow it down even more, it will just render this operation. So you can see it's lifting up and cutting down all of these to prevent us dragging that insert up the face of the part. So that's using no drag and also what we call skip unselected ops. Save you some time there. All right, so I'm going to deselect there, hit clear, and let me run the whole thing complete as fast as possible. So my part, the entire OD is finished, and I just need to finish the ID and then do the grooves. So I'm going to use that same boring bar that I used to rough to finish the ID. I have to be conscious of my turret positions, so I'm going to just bring that tool down, and I'm going to do a contour operation. I'm going to be cutting on the front ID. I do not want to use no drag on the ID. It's not necessary. I'm automatically going to deselect X plus because I learned my lesson when I did my roughing there. I'm going to click on here, extend up, select the down arrow, hold Control Shift, and click on this vertical line here. And then I can click do it. Let me put an empty space in there. And there's my finish pass for my ID. I didn't leave any stock in there. And so my part is finished turned with the exception of the grooves. So I'm going to deselect here, hit clear here, and as always I'm going to go up and save. Alright, let's work on our grooves. So we have 3 grooves up here and an ID groove. So let's figure out how wide these grooves are. Let's go up to my dimension palette. I'm going to use my horizontal dimension. I'm going to click one line and 150 there. So we have 3 grooves that are 150 wide. And I can click here. And that inner one is 200 wide. Alright, so I have an idea of what size tools I need to create. So I'm going to go and create my tool number 5. This one is going to be a grooving insert. Now this is the OD groove, so this is the appropriate OD touching point, touch off point for the insert. Now when I do grooving inserts, I always select the other button because I find these are a bit limiting as far as the widths and radiuses of my insert. I like to go to other so I can fully define my tool a little bit more accurately. So the tip width, that's the effective cutting width of this insert. And so at 150 wide, let's do 3 millimeters. Now remember, you can still use 3 millimeters and click the I button, which will immediately convert it to the metric equivalent of 3 millimeters. Save yourself a little time there. Let's put a tip radius of 2 thousandths. Insert width. I'll use this as if it's one of those kind of double-ended dog bone inserts. So the insert width is the body width, not the cutting width. The tip width is the cutting width. Insert width is the body width. Thickness, that's top to bottom. That's really just graphics, so there's no reason to change that. This is the length of my insert. You can make this match as much as you would like to your actual insert. Say it's 5/8 of an inch. Face angle, this is a 90-degree flat insert, so that will be 0 there. And tip length, maybe I can put 0.15 in there to make it look a little bit more representative of a double-ended grooving insert. And then back relief is just graphics, so I'm not going to mess with that one at all. So, oops, sorry, tip length, there we go. So that kind of looks like a decent insert, so let's go ahead and move on. So I'm going to bring that tool down, and I'm going to use the roughing process to rough these grooves. I'm a big fan of that instead of using the groove 74-75. So in using the roughing process, it opens up the process that we're pretty familiar with here. And we are going to be machining forward as always. We are going to be machining on the OD of the part. And the rough type, we're going to change that to plunge. Now, we're going to be plunging this. So the cut angle is very important to determine the direction of the feed. So we're going to be feeding down towards the center of the spindle. So if you think of a clock, in most CAD CAM systems, all CAD CAM systems and CAM systems, how they determine the angles are determined by essentially a clock, if you think about it. So the 3 p.m. position would be 0 degrees. Noon, 12 o'clock would be 90 degrees. 9 p.m. would be 180. And down towards 6 o'clock, which is where we want to be feeding, is either 270 degrees or negative 90. So we do want this to set according to the 6 o'clock position because we want to feed downward. So that's why this is set at negative 90. Now this is your step over here. So we want to have a max step over because we have a 3 millimeter. Let's go to 90 thou. That's going to be our max step over. You have some options here for center out cuts and multi-pass if you're using very wide grooves or if you're using very deep grooves. You can do some changes there to help. We're not going to dig too deep into that. And for our first cut, we are plunging, and we're going to have it default to 50% of our feed rate just on the first pass because that's when we're using the full width of the grooving insert. We are going to be using auto clearance still. Now for grooves, I typically change this a little bit smaller. I change my material only clearance to 10 thou, and that's going to reduce the amount of air cuts that we do with our grooving. I'm going to set 2 thousandths worth of stock on my radius and 2 thousandths worth of stock on both sides of the groove. And I think I'm ready to set my markers. So I'm going to set my markers simply on this first line here, and you can actually do the OD if you'd like. It's set to material only, so it's not going to machine anything on the diameters. And I put my back markers using Control and Shift back here. I'm cutting, all the grooves are highlighted in blue, the tool's on this side. So if I click Do It, there are my roughing passes. It's one step over here and then one step over here. If I run my OpSim, rewind, use skip unselected ops, slow this down. There's my grooving tool coming in and doing 2 passes to rough that out. If I turn on my geometry overlay, I can see my 2 thousandths worth of stock on the bottom and all of the walls there. So there's my roughing pass. Now what I can do is I can open up this process, and remember I want to convert this to a finish pass because I'm going to use the same tool and immediately finish these grooves. So I'm going to go down, right click, and I'm going to change this process because we're roughing right now to rough out that groove. We want to change this process to contour so we can finish the groove. So for finishing, I am going to be cutting forward. I am going to be machining on the OD. I am going to take my material only clearance to 10 thou because I'm grooving. There's no stock that I'm leaving for a subsequent finish pass. I want to make sure all my cut direction axes are back on. And I do want to select no drag. If I didn't select this, it would take the tool and drag it in there and drag it up the walls. So by clicking no drag, it's going to cut down towards the bottom, cut across, lift up, and then cut downward direction on both the front and the back walls. Now, because I've got my markers set on the outer diameter of the part, it's going to include all the geometry that's highlighted in blue, including these corners, these upper corners. So using this, I can automatically add a corner break in there. So say I wanted to put a 5 thousandths radius on all these corners. It will automatically radius all of these corners because they're included in between my machining markers. This one here, and all of these, and this one here. So now, remember, I don't want to click redo. I want to click do it because I translated this from my roughing process. If I click do it, there is my finish pass. And you see it automatically radiuses both of these sharp corners. Oops, let me go back to where I was. Now the toolpath looks off center because remember it's compensating for the 3 millimeter width of the groove tool. So that's why it's all the way over here. And there's my OD finish pass. So if I click clear here, go back into my OpSim. I can click play. Oops, I have to rewind. And now I can click play, and there's my tool coming in here and radiusing all of my edges. So I have a nice little radius there. And my OD grooves are finished. All right. So let's move on to my ID finish, or rough and finish the ID groove. So I have to create a new tool for that. So because, let me show you this really quick. Because the last tool I created was a groove, when I double click this, the new tool is going to be a groove. So if I were to have, say the last operation was a drill, when I go to create a new tool, my new tool is going to be that last one. So if you're creating a tool similar to one that you've already created, go ahead and open up that tool. Then double click on new tool, and it will carry over a lot of the information that you've done before. So save yourself a little time and piggyback on some of your earlier efforts. So I'm going to use the same width tool on the inside of my part, the ID of my part. So I really don't have to change much in here except for maybe my length. Because it's a relatively small bore there, I'm going to change my insert to a shorter length. And then obviously, because I'm machining on the inside of the part, I'm going to change my touch-off location to my ID groove. So remember, make sure this touch-off looks like how the tool is going to look in the real world. There's my touch-off on the end and the end of the tip of my insert. All right, so this tool is created. I'm going to bring it down, and I'm going to go back into my roughing process. I'm machining on the ID, and my rough turn again is going to be plunge because I am grooving. So when I click plunge, my plunge angle, it can tell because of the orientation of the tool that I'm plunging, remember the clock, towards the noon position, and the noon position is going to be positive 90 degrees. So that's cutting in the right direction, the correct direction. There's my step over. I'm using a 0.118 width tool, so I'm going to be cutting over 90,000th. My first plunge is going to be reduced. I'm still using material only, and it's using the stock that I used the last time I roughed. I'm going to leave 2 thou on this face and 2 thou on both of these walls here. So I'm ready to set my markers. So I can click on here and hold control and click on here. And again, look at what's highlighted in blue. The outside of my part. That lets me know that my arrow was selected in the incorrect direction. So if I have my marker set, I can go ahead and click do it. And there's my roughing pass, and you can see it retracting out of the face of the part. Now I can click deselect there, clear this out, and we'll go ahead and bring that same tool back down. And let's do our contour. This will be our finish pass. So we're going to be cutting forward. We are going to use no drag because we don't want to drag the insert up the wall here. We're going to cut down towards the bottom of the groove on both faces. We're going to be cutting on the ID of the part. And I do want those corner breaks. I want to radius both of these corners. So I need to make sure I include those corners when I set my machining markers. Now, if I were to have set my markers here, it would still finish my groove. But because these radiuses are not included, it won't radius these upper corners. So if you do want the upper corners to be radiused, make sure you set your markers outside of the groove itself. So we are set to material only. And if I click do it, even though this diameter is smaller than this diameter, it'll radius this one, cut over, come up, and then cut down and radius this one. So my ID of my groove is now finished. So I'm going to, again, deselect, clear, and save. Our entire part is roughed and finish turned. Now, it isn't represented in the solid model. I'll bring it back out. But there is an ID thread. So we're going to do some single point threading on the entrance to this bore here. Now the thread size that we're going to machine on this diameter here is 7/8 14. 7/8 major diameter, 14 pitch, 14 threads per inch. So we're going to go in here and create our threading insert. Now we have a couple different configurations of threading inserts that we can use. A groove style threading insert, which is kind of a universal tool. It's a bit wider. You can cut many different pitch lengths with this, from 32 thread to 8 threads per inch. Or you can use a top-down notching insert for more production. Now this style insert, you have to use the one pitch. It's set. You have a 32 insert, a 24 pitch insert, 16, a metric 1.5 insert. So it's a fixed thread pitch per insert. So we'll go ahead and set up a lay-down threading style insert for this one. So because we're on the ID, this is the correct touch-off position. Our style of thread is going to be UN, and you can see you can generate quite a bit. The ISO would be metric. We're going to do a UN thread. We're going to do a 14 pitch, and it's a 3/8 included circle, inscribed circle. Now, real world, if you're touching off these inserts, it's not often that you would compensate to the tip of the actual cutting edge. Most of us just touch off on the left side of the insert. So consequently, you'd want to click on this left side to denote a more accurate touch-off point for the insert. So I'm going to make sure I do that. So my insert is created. I'm going to bring that down. And I'm going to create a single point thread, which is, this is your process here. Now, this is version 25, so it's a bit of a busier tile here, but you're only going to use a bit of the information in here. So what I like to do, my preference is to define the thread from the parameters in this window instead of from the shape. By defining it from the parameters, I can give it every bit of information it needs to generate the thread form without having to select on any geometry. So that's my personal preference. I am going to be machining in the Z- direction from the face deeper into the part, and I am going to be machining on the front ID. I am going to use material only, or auto clearance. Now you have some options up here. There's a multi-pitch if you wanted to have different thread pitch lengths, so you could do 1 inch of 32, 1 inch of 16, 1 inch of 12. If you have an application like that, there's a variable pitch application where you can have the pitch of the thread morph from, say, 16 pitch to 8 pitch. You can have it morph, but we're going to be doing a constant pitch, a constant threads per inch. And our threads per inch are 14, and you can see it automatically calculates a metric. If you were doing a metric pitch, you could put the 1.5 in there, but we're doing 14. So I'm going to skip this for now, and I'm going to jump back over here to the left. Now again, I said we're doing the front ID. It's a UN style thread. And this nominal is going to be the major diameter of the thread. Even though we're doing an ID thread, this is the major diameter designation of the thread, which is 0.875. It's not a tapered pitch thread. It's not an NPT or a pipe tap. And we are doing one thread lead. We're not doing a double lead or a triple lead rapid threading process. We're doing a single helix thread around this part. Now the major diameter, you could actually go into the machinist handbook or your technical spec and look for the actual tolerance for the major diameter, and this may be 0.872 or something like that. But in general, I leave this the same as the nominal, because when we're running this first part, we're going to use our tool offset and offset the insert down and sneak up on the thread pitch diameter anyways. But if you wanted to put the actual major diameter in there, you could. Because it knows the thread pitch, 14, it's going to auto-calculate the minor diameter and auto-calculate the thread height. So there's nothing you need to worry about in there. So up here, this is where we're going to start and finish threading on the bore. So I like to select tool front because that's where I'm actually touching off my insert. And these two boxes will enable you to kind of ramp out your thread and ramp into your thread if you need that in your feature. But in general, you really only need these lower boxes, which tells you where you're going to start threading in Z, which for me is going to be 0.1. I like to start off the face of my part. And then where's the back of my thread? Now, this is also another feature where you can interrogate your geometry or your model. So I'm going to click in that box, and I'm going to hold my Alt key, and I'm going to interrogate this back wall. So that's where the end of my tool is going to be. Now, I don't want the tool to come in and actually kiss this face or hit this face. So I'm going to change this to 5.5. So I know that this face is negative 1.6, and I'll just stop a bit shy. Make sure I thread past the diameter, but I don't end up running into this face. Now, in coming down, you can designate how many threads you want to cut passes. So I can do one finished pass if you just, maybe you're cutting plastic and you just want one single pass to cut that thread. You can do a constant cut load where your depth of cuts to cut the thread are the exact same. Or you can do a constant load, which means that your depths of cut will start here and continuously reduce until you get to your last cut. And I'll typically set that to 1 thou, my last cut. And depending on the pitch of the thread, let's try starting at 2 thou and see how many passes this gives us. If you needed spring passes, you could add them in here. And then, because I said we're using this from parameters, there's no geometry that we need to select to cut. So we're just going to immediately click Do It. And there is our thread shape with our retracts. And if you zoom in, you can see how many thread passes this is going to give us. It's 1, 2, 3, 4, 5. And by changing this first pass, if I change that from 20 to 15 thou and redo, you can see I can get many more passes in there. So you kind of want to configure this according to the material that you're cutting, the length of the thread, the rigidity of your threading tool on the ID, and figure out how many passes is going to work for your particular application. All right, so my part is threaded. I can deselect that, hit clear there, and let's go to our OpSim. And if I click rewind and select this op, it will pre-cut my part, and then I can watch my threading process. And I think I said 5 passes, so that should be the third one there. All right, I could even go to my section, full half section, and you can see the actual thread form. So there's my ID single point threading operation. So I'm happy with that, so I'm going to deselect. I've already hit clear, and I'm going to save. All right, I'll turn off my OpSim. And let's bring our part back out. So our part is totally turned, OD, ID, thread, and we just have our milling features. So we have a spline, we have a couple of face screws here, and some OD features. So the first thing I'm going to do is we're going to machine these face grooves here. So to do that, I need to be in a different coordinate system. So I'm going to go to my XY plane. And you'll notice that when I switch to my XY coordinate system, which is what I need for my live tools on the face of the part, my geometry turns this purple color. And what that lets me know is that geometry lives in a different coordinate system and is associated with a different coordinate system. So for me, I don't like to mix geometry from different planes and different coordinate systems in the same work group. So because I switched to my XY plane, I'm going to create a different work group. So going back to that, this is my original work group. I'm going to slow click on that and relabel that, and I'll call this my turned profile. And you can name it anything that makes sense to you. Now when I go to my XY plane, I'm going to create a new work group. And I'm going to call this my face slots. Something that makes sure you know what resides on that work group. So I'm in my XY plane. So I need geometry to machine. So I'm going to turn on face selection. And remember, face selection enables you to select individual faces of your model. So I'm going to select just the bottom of one of those grooves. Just one for now, and I'll show you why. If I right click, I can extract the edges of that geometry. Make sure you click do it. And then remember, turn that off when you're done using it. So you see I have the geometry that's on the bottom of this slot. Now if you remember, I can dimension this radius by my dimension palette, or I can go to plugins, show position if I wanted to figure out how wide this is. So if I click on this icon until I get to curve, I'll select my model, and then I'll select that radius. And so it's a 40 thousandths radius at the end of this slot, which lets me know that the width of the slot is 80 thousandths. So I need to create my tool. I have the information to create my tool. So I'm going to click on tool tile number 8. Again, it defaults to the last tool I created. And I'm going to create a finish end mill. Now, finish end mill and rough end mill, functionally, they're the exact same. The only difference is that if you used a rough end mill, selected this, in your comments, it's going to say rough end mill. So I typically reserve that to corn cob cutters and the like. So I'm going to use finish end mill. And I'm going to make this diameter because our slot is 80 thousandths wide. Let's go 0.0625, or you can do 1/16 equals. And then my flute length, let's make it 3/16 of an inch long and overall length of 2. Now I typically like my tools to look a little bit like what they did in the real world, so I'm going to change it from a straight length shank to a tapered shank. So 16th end mill, I'm going to tell it has a 1/8 inch shank, and then this distance is going to be 0. So now my tool looks a little bit more realistic. Again, you want to make sure the orientation is in the correct direction. The tool needs to be facing the chuck because I'm machining on the face of the part. So I'm going to close this out, and I'm going to bring that tool down. So I'm going to machine this because my tool is wider, over half the width of this slot. I'm going to cut it as a contour. Now, one of the things you want to make sure you do when you get into your process is make sure that the coordinate system that the process is going to be machining in matches what it does out here in the workspace. So I'm viewing my XY coordinate plane. You want to make sure that you want to be machining in the XY coordinate plane because they're not the same. You could have this might have defaulted to some other coordinate system. So make sure you check this if you have any issues to make sure that the machining coordinate system selected is the one appropriate to the feature that you're going to be machining. So I'm going to take my entry and exit and make them relatively small because this is a small tool and a relatively small slot. I'm not going to leave any finished stock because this is just a tutorial. And over here I have my 4 boxes which all designate the depth of the cut. So this box here is the one I always start with. I always start with the lower left, and that tells me where I'm going to start machining from. So I'm going to start machining as far as the depth on Z0. That's the face of my part. And how deep is the slot? How deep am I going to be machining for this process? I don't know. If I don't have a drawing, I have the model, I can interrogate for that. So I can click in there, hold Alt on my keyboard, and I can click either on the geometry or the bottom face of that groove. And it tells me that the groove, that slot, is 30 thousandths deep. Now, I can't advise this enough. You are the brains behind the operation when you're programming and developing process to machine a part. So don't rely on what it gives you if it doesn't make sense. So for instance, if I were in a different coordinate system and I interrogated a feature and the number just didn't make sense, I know that that's not 179 deep. I know that the face of my part isn't 0.65. If these numbers don't make sense when you interrogate them, you want to think about it. Double check your coordinate system. Make sure you're in the appropriate coordinate system. Then when you interrogate for these numbers, it does make sense. Make sure the numbers it gives you make sense. Okay, So my Z step, this is the depth of cut. So it's a very small end mill. So let's go 15 thousandths. Your Z step is what you desire, and this is the actual depth of cut, and it's going to do it in 2 passes. So if I put something in here like 12 thousandths, it's going to kind of give you what you want but not go over. It needs to cut it in an even number of passes, so the actual depth of cut would be 10, and the number of passes would be 3. So we'll do it in 2 passes. And because I prefer not to plunge that tool into the part, I'm going to ramp down. So I'm going to have it start at Z0 and continuously ramp down the entire contour of the periphery of this slot. Now I need to simply select my machine markers. So when I'm machining slots with a contour process, I typically start it at the end of the slot, because most times you're machining a slot, it's a functional slot. If you have a pin residing in there, I'd prefer not to start on the edge of a slot, so I'll start at the end. Now when you select your markers on a piece of geometry, it sets the markers wherever you click. Now the shortcut to automatically center these markers on a given piece of geometry is just to simply hold Control and click off in space. Then it will automatically center your machining markers on a given piece of geometry. I want to cut in this direction, and I want my tool to be inside the geometry so I'm climb milling, and I can click Do It. And there you see my lead in, and it machines the slot. If I go to the top view, you can see that. Let's go to home view and zoom in. You can see the 5 thou straight line lead in, 5 thou radius, which are right here. Then it cuts the contour, and then at the last bottom cut, it will lead out. So there's my cut. Now, we only have one, we have 2. So what I can do is I can go into my Rotate tab here, and I can duplicate that toolpath by rotating around the origin of my part. So I can go, I want to duplicate that one time at 180 degrees. And if I click Redo, then I have both of my slots. Now here's where you have to think of your particular machine, because I'm doing this right now in position mode, which means it locks the C-axis, which when you're in live tooling mode, your chuck becomes an indexer essentially. So it's going to lock my C-axis at 0 degrees, and it's going to generate this toolpath using the X-axis and your machine's Y-axis. Now in the real world, in general, most machines, you can't bring the center of that tool too far below the center of the part. So if I were machining this slot down here, it may result in an over travel. And also, most of the time, your Y-axis is a bit limited. A lot of times it's plus or minus a couple inches, 50 millimeters. So if you have a large diameter slot, which this isn't, it could generate over travels in that regard. So what you could do is then check polar cylindrical. If you cut it in polar cylindrical mode, it converts the XY movement to XC movement. So in polar cylindrical mode, it'll lock your Y-axis on 0, and you will only see C-axis movement, C and X-axis movement machining these slots. So it prevents any Y-axis over travels, and it prevents any X-axis over travels. So if I go into my OpSim, I'm going to turn off the overlay and go back to full part and redo, and you skip unselected ops just to watch this milling operation. I can see my tool come in. And I can actually see my part rotating, just as if it would be in the real world. Let me turn on edges to make this look a little bit more vivid there. Maybe that's too busy. So you can actually see your part rotating, your Y-axis is on center, and your C and X are doing all the movements. All right, so our face slots have been machined. I'm going to deselect, clear, and as always, save. All right, let's move on to the OD splines we have around the periphery of our part. Now, because they're on the periphery, we also need to be on a different coordinate system. So I'm going to jump into my YZ coordinate system, which is the coordinate system I'm going to use to do all the radial milling on this part. Now, again, when I switch this coordinate system, you see that that small slot geometry turned purple. That's in a different coordinate system. So to me, that's a flag to go to a new work group. Again, this is all personal preference, but I kind of advise it, and it keeps your workspace a bit neater and a bit more organized. So if I go to work group, I'm going to call this my OD Splines. How about that? Okay. Now, I only need to machine one of these splines, and I can rotate and duplicate it around. So if I go to my home view, it gives me a bit of a normal view. So I'm going to pull the geometry from this center spline. If you pull an offset geometry, it's not going to go very well. So you want to make sure you pull the geometry from this center spline. So to do that, I'm going to go into face selection, and I'm going to select the bottom of that slot. If you rotate, that's the one I'm going to be picking, and I'm going to right click on it and extract the edges and convert them to geometry. So I can click do it. If I turn off face selection, I now see I have the geometry for that groove. Now, I have to be careful of the geometry. So for now, I'm going to put my model away just because I can show you this tip here. This is the geometry for that slot. Now, because the slot breaks out into this conical face on the front and a conical face on the back, I'm going to turn on my labels just to illustrate this a little bit clearly. So labels are the designation for geometry that's kind of in the background of GibbsCAM. So if you hit Control L, it turns on the internal designations of the labels of your geometry. So you can see I have L1 and L2, those are lines. I have P1, P2, 5 and 6, those are points, but these N's are B numbers, and that stands for a Boolean, which means it's a spline. So that is not clean geometry. It's not a circle, it's not an arc, it's a series of hundreds of tiny line segments. So that's not good geometry, and it's not geometry that I would really want to machine to. So the way I want to machine this slot is I'm going to take a small end mill. I'm going to turn my labels off, Control L again. And I want to bring it down here. And I want to feed in up one length of the slot, step over in this relief back here, and then feed out to the front of the part, and then take my next depth of cut. So what I want to do is I want to create some geometry that will enable me to do that. So what I'm going to do is I'm going to zoom into the back of my groove here, into the relief. This is where I'm going to turn around. So I'm going to select this point and this point. And I'm simply going to go to my geometry palette. And I'm going to draw a line between those 2 points, P1 and P2. And so if I draw that line, I'm going to then parallel this a bit more than the width of my tool. So, well, first, let me figure out how wide my slot is. I can open up my geometry palette, and I can select this and this. 70 thousandths wide. Okay. So I'm going to parallel this wider than the tool. So because it's 70 wide, I'm going to use a 1 millimeter end mill to cut this slot. So I'm going to parallel this line 50 thousandths. And if I click draw a single line, it gives me both options of parallel line. I'm going to click the one I want to keep and then OK. So then I'm going to delete this line. I'm also going to delete that spline at the end of the slot. I'm holding Control so I can select all of these features. I'm going to select this point and that point, and I'm going to hit delete. So those are all gone. So this line that I created at 50 thou offset, I'm going to select that, hold Control, select this line, right click, and connect those two. Then I'm going to select that line again, hold this Control, select this line, right click, and connect both of those. So I have a nice line of geometry that I can turn around and go back into the other direction. Now, because I'm going to do this with a contour, I want to make this an open shape. I just need a U-shaped piece of geometry. So down here at the end, I don't need to parallel a line or anything. I'm just going to select this connector here, which connects this horizontal line to this spline. I'm going to select that connector, hold Control, and select this line. So instead of connecting these two features, two geometries, the spline and the line, I'm just going to connect the point to the line and turn it into what we call a terminator. So it's just going to act as an end cap to that line. So I'm going to right click and connect, and you see it turns into a little yellow square. I'm going to take this little blue square and connect it to this line and cap this line, connect. And then this line is yellow, so it's floating in space. I can delete it. So I have, if I put this away, a nice clean U-shaped piece of geometry for that end mill to machine this slot. Okay. So I'm going to create my tool. Now I already previously created a 16th inch tool. So I'm going to piggyback off of that. I'm going to create a similar tool so I don't have to put in all this information again. And then I'm going to double click on my new tool, which creates a duplicate of it. So all I need to change is the cutting diameter to 1 millimeter. So I'm just going to type in 1 millimeter and hit I. And now my tool is set to 1 millimeter. Maybe I'll make it a little bit shorter as far as the cutting length. I'll make it 3 millimeters in cutting length to make it look more representative. So there's my end mill. Oh, I need to change the orientation because I'm machining on the outer diameter or the periphery of the part. I need to create a radial tool. So my tool in reality is going to be pointed vertically. All right. So I can bring this tool down and I'm going to create a contour. So I do not need a radius for my lead in, but because I want to come in off the face of the part, maybe I'll put 60 thou in there to do a straight line lead in and a straight line lead out into this cut. Now, this is where you really need to be careful. The reason I always start in this lower left corner is because this tells me where I'm going to start machining at. And I'm going to start machining at this outer diameter, which I know is 0.75. And because it's 0.75, I can interrogate for my depth. And this is going to be the bottom of my cut, which I can either interrogate the geometry or this flat here. Now, the reason I start in this bottom left is because if you look right above it at your approach is still set to 0.1 from when we were machining on the face of the part. And this would be a crash. I need to make sure that my approach and retract are both higher than where I'm going to start cutting on the diameter. So I'm going to change this to 1 inch. And I'll change my retract to 1 inch to make sure I approach to X 1 inch. And then it knows where I'm going to be cutting from there. So I know it's a small end mill, but just because it's a tutorial, let's do it in 10 thou depths of cut. Well, let's do it at 20, save ourselves a little time there. So I am going to turn on retracts and turn off ramp down because I'm entering in space and exiting in space. Matter of fact, I'll turn off retracts as well. So when I'm generating toolpath, let me put the model away so this is a little clearer. When I'm generating a contour with an open shape, you can select the middle of the line and then you can play with your end and finish markers. But to me, it's always cleaner and easier to select the end point of an open shape. So I'm just going to click on here and you'll notice my markers are all set perfectly. All I have to do is tell it which side of that geometry I want the tool on. And I can go ahead and click, let me put it on this space here, do it. And there is my slot. Now you see I still have a rotation in there from my last operation, which I'm going to zero out. I only want 1 slot. And also you can see that my approach is tapered because it's still in polar cylindrical, which I do not want on this slot. If you look at my model, the walls are vertical and the bottom is flat, which means I have to machine in positional. So I need to be machining in positional mode instead of polar cylindrical. So I'll go in there and change that. And then there's my slot. So if I go into my OpSim, I can see myself coming down and machining that slot. So that's one done. And all I need to do to duplicate all of these around the periphery of the part is open up my process again and go into my rotate tab. Now I know that there are 36 slots around here. So I can go in here to duplicate. And I know I want to duplicate 35 times because I already have one. And if I didn't know the angle in between the slots, I could simply go in here and go 360 divided by 36 total slots equals. And there's my 10-degree angle in between each of those slots. So if I now go redo, there's all of my slots around the periphery of the part. So if I click clear here, go back into my OpSim, I'm going to turn off skip unselected ops and just run it all the way from the beginning. There's my thread, and there's all of my periphery splines. All right. So I'm going to make sure I save. And we can now move on to these large flats on the OD. So I'm going to keep it in the same work group because I'm going to keep it in the YZ plane. So I'm going to extract the geometry that I'm going to need to cut this slot here. And the only piece of geometry that I will need is this lower edge. So I'm going to turn on edge selection. I'm going to select this edge, right click on it, extract the edges, and click do it. Then make sure you turn edge selection off. So I have this nice piece of geometry here. So to cut this, I'm going to create a 1/2 inch end mill. So I'm going to go to end mill. It's vertical, same as the last tool. And because it's a larger end mill, I'm going to do it as a straight shank with a 0.5 diameter. Let's give it 1.25 inch length of cut and maybe a 3.5 inch overall length. So there's my 1/2 inch end mill, and it is oriented in the correct direction. So I'm going to bring this tool down, and I'm going to machine this also as a contour. And again, I want to make sure I'm in the correct coordinate system, which is the YZ plane. That is correct. So where is the top of my cut? As you see, it's on a cone, and it's also on a radius, so it would be a bit difficult to determine where exactly I'm going to start machining for. But I wanted to illustrate something here about the left side and the right side when you interrogate geometry. So I'm going to click on this face to interrogate. So on the left side here, if I interrogate this face, it gives me the highest point on this face. But on the right side, if I click on the exact same face, it gives me the lowest point on the face. So it's a handy tool to determine where this odd-shaped face is, the highest point on it. And so I know that the depth of this is now roughly a little bit under 3/16 inch, 0.1873. So let's give myself a 0.2 depth of cut. I'll do this in 2 passes, depth-wise. Now again, look at my approach and my retract. They're lower than that point. So I'm going to give myself a 1.5 inch approach and a 1.5 inch retract. I do want to do retracts here as well, so I'm not dragging across my part. So if I set up my markers, again, it's an open shape, so I'm going to click on the end point here. Tools on the correct side, I'm cutting in the correct direction to climb mill across there, and I can click do it. Whoa, see that? Remember, go into your rotate and get rid of your rotations from the previous operation. So I'm going to just zero that out. I don't need to zero the angle because it knows I'm not going to rotate. And then I can click redo. And there's my pass across this face. Now if I'm concerned about approaching into the material, I can give myself maybe a little bit more straight line lead in and lead out. Now you just want to make sure that because we're using the y-axis on this, you're not extending further than the travel that you have allowed on your particular machine. Maybe I'll take that a little bit less just to mitigate that risk. And if you're concerned that your tool isn't wide enough to cover this face, you could also give an extra offset here. So I can give one offset and maybe give a 0.2 step over. And then if I click redo, it'll do it in 2 steps just to make sure it covers that entire face there. Okay. Then I can go down, and remember I have 2 slots here, 2 flats here. So I know that this is 70 degrees. So I can go in here, and you see these operations are stacked because of that additional offset. And this actually gives me a good opportunity to talk about changing tools. Now say for instance I did this flat, and I didn't want to take the cycle time to do 2 passes. I could take out that extra offset and do it in 1. But I could just say, well, I don't want to do 2 passes there. I want to do just 1 pass with a wider tool. If you go in here and just change the width of your tool, so maybe I go 5/8 of an inch, all I have to do is redo that up and watch your toolpath compensate for the larger tool. So now you know with 1 tool you can go across that entire flat without having to use an offset cut. And if I want to machine the second slot at this angle, I know that's a 70-degree angle. I can go into there, go to my rotate tab, and I can duplicate this 1 time. And if I put in 70 degrees and redo, it's like, oops, 70 degrees is the different direction. So I would just simply go ahead and change this to a -70. Redo, and now I have both of these flats oriented properly. All right. So we're getting close to the end of this part. I'm going to go ahead and file save. And let's work on the holes of the part. All right, so what I'll need to know is the diameter of the counterbore and the diameter of the through hole. Now I do need a counterbore. If I'm going to helically interpolate this with an end mill to do the counterbore, I'm not going to plunge it. I'm going to use a smaller end mill and do a helical interpolation. I need to pull that geometry for that counterbore. So if I turn on, well, let me do face selection. I'll do face selection and select the bottom of the counterbore. If I right click and extract the edges, I'll get the through hole and also the counterbore. And if I pull up my dimension palette, I can quickly determine that that's 300 diameter. And then that's 157, which is roughly 4 millimeters. All right. So I'm going to go ahead and delete those. And so for my 300 counterbore, let's do a 3/16 end mill. So I'm going to go 0.1875 and 0 corner radius, and I'll make this flute length a bit shorter, maybe 5/8. So I'm going to bring this tool down, and this is also going to be a contour. So I'm going to make sure I'm in the right coordinate system, which I am. Oops, let me take out my, no, I'll leave the rotations in there. I do need those rotations. So I'm going to find out where is the top of my material that I'm going to be machining, which would be this flat. And then where is the bottom of the counterbore? So I can either interrogate this flat bottom or the vertical wall, because remember, it's going to give me the lowest point. So it's 0.21 deep. And how about a 30 thou depth of cut? I'm going to ramp down, and I'm going to turn off retracts. Now for my lead in and lead out, let's try 10 thou and 10 thou radius. I always advise get something on the screen because it's so easy to go back and tweak if I need a larger lead in and lead out, or if I need to change my depth of cut. Get something on the screen and just massage it from there. So I'm going to, my approach and retract are in a safe distance. So I'm going to select that geometry. And remember, if you hit Control and click off in space, it'll automatically center those markers. I want my tool on the inside, and I want to cut in this direction so I can climb mill down. And I'm going to click do it. And there is my cut. It's a continuous helix from the top of my part down to the bottom of my part. And I can even probably give myself a little bit larger lead in and lead out. There you go, that looks a little bit better. All right. And because in my rotate tab, I had a duplication in there at -70 degrees, I have both of my holes being machined. Okay. Again, I'm not in polar cylindrical. I do need my y-axis on this, so I am in positional mode. Okay, so I'm going to close that, deselect, clear, and save. And let's work on the last feature of this part, which is these through holes. So I'm going to go in here and create tool number 12, and that's going to be a drill. And again, it's 4 millimeters in diameter, so I can hit 4 and click on I. And because we'll use this as a 140-degree carbide drill, it's going to have a designation of times the diameter with the length. So let's go 4 times 5 times D equals, and then automatically convert that, oops, that was 20, back to inch. So it's a bit over a 3/4 inch length of cut for this drill. All right, so I'm going to bring this down, and I'm going to go to my hole drilling. We're just going to do a standard feed in, wrap it out. I'm not going to worry about cutting parameters. So the top of where the point at which I'm going to start drilling the depth is going to be the bottom of the counterbore. So I'm going to click in this box and Alt interrogate the top of that. Now remember, you can designate this hole depth by the size of a countersink, the corner of the drill, or the tip of the drill. And I care about the corner of the drill. I need to know that that breaks all the way through the bottom of this hole. So I'm going to click in this box and hold Alt and interrogate the inner diameter of the bore, and that gives me the lowest point of the bore in depth. So I'm going to give myself a little bit more. So let's go 0.45. I want to get closer to the center of the part, make sure the corner of my drill breaks through. And I could select either one of these circles. When you're drilling a hole, you can drill to the center of a circle or to a point. So either one of those would be appropriate to use to drill this hole. Again, my rotate, I want to do 1 time in -70 degrees. And if I click do it, there's my hole through the part. All right, that looks like to be my last operation. So I'm going to deselect, clear, save. And let's go into our OpSim and give a final look at our part. So if I do my OpSim, I can rewind. And I'm actually going to change my color scheme. So if you want to see the different tools and what features that it's machining in your OpSim, the standard OpSim is kind of this gray mode. But you can go to the cut color mode, and you could say, I want each of my operations to have its own color, and the surface that it's machining is going to be appropriate to that operation. Or you could go by tool number. Each tool has its own color. So if I run op mode and then I click play, you see each feature that it machines is done by a different color tool. So this this flat here is going to be done with the, this process here is going to be done here. So that matches that color. And then the through hole is green, so that matches the green process. So if you want to be able to delineate or determine which feature is done by which process, you can use these cut color modes. So I'm going to go back to the green color, and I'll just go ahead and play. And you can see all of the operations that we've completed to machine Op1 of this lathe part with live tooling. Increase the speed there. And there's our part. If we do a cutaway view, you can see that the hole does break into that O-ring groove. I can do a half section here. And that's our part. I hope you've picked up some tips and tricks to help you process parts and some of the reason why and how we do things. And again, I advise you to reach out to Virtual Manufacturing if you have any questions, and I hope you've enjoyed. Thanks a lot.